In this video, we're going to look at graphing linear equations and functions. And our goal is to identify points in a coordinate plane and then also graph equations using a T-chart. So before we get into graphing equations, we want to look and see if these points are solutions to the equation. This will mean it will tell us if the points are on the line or not as well. So each point represents an x and a y. And to see if they're solutions, you're going to plug them into the equation and see if you get a true statement. So if I plug in 3 and then x is 3, then minus y minus 4, is it equal to 7? Is that true or not? And so you might be able to see it right away, or 9 minus 4, is it equal to 7? And 9 minus 4 is just 5, and 5 is not equal to 7. So this is not a solution. And so all those would be not equal. Okay, let's plug in 1 and negative 4. And once again, you may want to mark x and y. So you get 3 times 1 and then minus 4 minus negative 4. So let's put in another minus there. Is equal to 7. Plug in negative 4 for y. And then 3 minus negative 4 would be like 3 plus 4. So 7 is equal to 7. This is true. So this is a solution. And pause the video if you haven't already and try C and see what you get there. 3 times 5 minus negative 3 is equal to 7. And so you get 15 and then plus 3 is equal to 7, which is not true because 18 is not equal to 7. And so this is not a solution. Okay, so this says, can you name 3 other points that would be solutions to the equation given in example 4, which is actually example 1? And yeah, we can. Actually, we can name as many as we like. Let's just do one other one. So let's name one other point. So to do that, just pick an x value or a y value. Normally start with x. Let's say x is equal to, we didn't use 2 yet, so let's use 2. And so 3 times 2 minus y is equal to 7. So we pick x and then solve for y. And so we can multiply this, you get 6 minus y is equal to 7. Subtracting 6 from both sides gives you negative y is equal to 1. And then divide both sides by negative 1 to get y is equal to negative 1. And so 1 point would be 2 and negative 1. So that's a solution. And you could pick other x's if you like to. We're going to move on here. Okay, example 2 says, is 4 negative 1/2 a solution to the equation? So do the same thing. This is just a fraction. So we're going to plug in 4 for x and then negative 1/2 for y and just see if it's true or not. So we have 2 times negative 1/2 is minus 1 is equal to 7. And that is not true. 3 is not equal to 7. And so the answer to the question is just no. It's not a solution. Okay, here are the steps for graphing an equation from a table of values. And this is how we're going to graph in this video. Later, you'll probably learn some of the shortcuts, and that's okay too. But graphing from a table is always a fallback method for graphing, whether you're graphing lines or other curves that you'll eventually learn as you go through algebra 1 and beyond. You can always go back to picking an x value and then solve for the y value. And then repeat this process with as many points as you need. In this case, we're only going to look at lines, so we can just use a straight edge to connect the points. Okay, so we're going to go through this first one kind of slowly, and then the next few will go a little quicker. So you get to pick some points. For this, I'm just going to pick a negative 1, 0, and 1. And you don't really have to. If you just want to do 0, 1, 2, those are good points also. I just always kind of try to pick a negative value and a positive value. And really, it doesn't matter what points you pick, but don't pick something like, 20 or 19. Like, pick a pretty easy number. And then we'll put the work over here. If x is -1, then you get 2 times -1 plus 3. So you get -2 plus 3, which is 1. Okay, when x is 0, which is our next value, you get 2 times 0 plus 3, which is just 3. And then because this is a line, we start to notice a pattern. So these are 1 apart, and these are all look like going to be 2 apart. So I think this is going to be 5. Look for a pattern. A line will always go up by the same amount each time. But you can also plug it in. Y is equal to 2 times 1 plus 3, and sure enough, y is equal to 5. Okay, and then when you plot these, you got to be careful that you are not making mistakes with your points. So -1, 1 is here. 0, 1, 2, 3 is here. Notice that that's also right there. And then 1, 5 is here. So we have 3 points. Really, you only need 2 points for a line, but we're going to ask you to do 3. And then connect them with the straight edge. I don't have a straight edge here. I'm just going to do the best I can. And that makes your line. So then we want to know, is -2, -1 a solution to the equation? How does this point relate to the graph? So if it's a solution, then it will be on the line. And if it's no solution or not a solution, it is not on the line. So let's see what happens at -2, -1. You might be able to tell. So -2, -1, that looks like it's pretty close, right? So here's the point in question. It looks like it's probably on the line. And if your line was drawn perfectly straight, that might be enough to convince you. But to really be sure, you probably want to plug in the point. Let's just add it to this table. What if I plugged in -2? So y is equal to 2 times -2 plus 3. And sure enough, I get -4 plus 3, which is -1. So yes, it is a solution because it is on the line. Okay, and then we're going to go through these next few kind of quickly. Pause the video and try them on your own for practice, and then watch the video to see how you did. So let's mix this up a little bit. Let's do 1, 2, actually 0, 1, and 2. So when you plug in 0, this just zeroes out and you get 3. When you plug in 1, 1/2 times 1 plus 3 is 1/2 plus 3, which is 3.5. And you might see the pattern. It's going up by 1/2 each time. And then when you plug in 2 times 2 plus 3, you get 4. And sure enough, it goes up by 1/2 each time, which is also the number in front of x, is 1/2. Okay, so 0, 3 is here. 1, 3.5. That's always kind of funny, but it's in between 3 and 4. And then 2, 4. And then we'll connect those with a straight edge would be great. I'm going to kind of eyeball it. And then we want to know if 6, 8 is a solution. So 6, put that on your XY table, and then just see what you get. And you get y is equal to 3 plus 3, which is 6. And so when I plug in 6, I get 6. So 6, 8 is not a solution. So just no. And that means it is not on the line. All solutions are on the line. Okay, for this one, we're going to go back to, actually, let's look at a different trick here. So fractions are bugging you. You can use the number on the bottom of the fraction if you want to clear it out. So 5 is here, so let's do -5, 0, and 5. And you don't have to. You can just do -1, 0, 1, or 0, 1, 2, 3. Use 0 each time, though. But this is just kind of a trick to get rid of the fraction. So then if I choose -5, then those will cancel. So 2 times -5 is -10, divided by 5 is 2, -2. So this gives you 1. When you plug in 0, you get 3. So 1, 3. And look at the pattern. These are the same distance apart, and so these should be the same distance apart. So it looks like I'm going up by 2 for every 5, and I should expect this to be 5. So let's see what happens. Y equals 2/5 times 5 plus 3, and sure enough, the 5's cancel, and 2 plus 3 is 5. So I have -5, 1, 0, 3, and 5, 5. Okay, this line is always one of the trickier ones. Y equals 4. There's no x value, so what do? Okay, well, what this means is y is always 4. So what I would say is just fill in some numbers, right? And y is always 4, so y is always 4. It doesn't matter what you pick for x because y is always going to be 4, but give yourself some numbers. Let's use 0, 1, and 2, and then plot those points. So 0 is 4, 1 is 4, 2 is 4. Your line is a horizontal line. So if y is equal to a number, then you get a horizontal line. Whoops, let me move that up a little bit. This is a pretty important pattern. But remember, if y equals a number, it's horizontal. Memorize that. That'd be good, which is weird because the y-axis goes up and down, or it's vertical. But then just fill in 4s for y, and then pick x as whatever you want it to be. In a similar fashion, if x is equal to a number, then just put that number in for x. So -3, -3, -3. And it, once again, doesn't matter what you choose for y. So let's just choose 0, 1, and 2. Now, this is a little weird because we are starting, well, you're still starting with the x's, but the numbers you picked were y's. We haven't done that yet. So when you just be careful, you go over to -3 and 0. So we got a point here, -3 and 1, and -3 and 2, and you get a straight vertical line. So x equals a number means the line is vertical. Okay, let's call domain and range. So you remember the domain is all the inputs, or the x values, and range is all the outputs, or y values. And so if we put this restriction on domain with the x's, what's called a domain restriction, that just means you can't use any x's that are, and I underline the equals to, that are less than 0. So x's have to be greater than or equal to 0. So just, that's fine. Choose your x, 0, and then 1 and 2. Okay, now this is a little bit, or can be a little tricky. But let's get y by itself. Let's subtract 3x first. And if you do that at the beginning, you'll probably save yourself a little time because you only have to solve the equation once, then multiple times. So y is by itself. And so now you can just plug in your numbers like you did before. So pause the video, take a minute to do that. You plug in 0, you get -2. You plug in 1, should have moved that over and give myself more room. You get -5. Yeah, -5. And then when you plug in 2, you get -6 minus 2 is -8. And you do see a pattern here. We're going up 1, and then we're subtracting 3 each time. Now, this one's a little different when you graph, because when you draw the line, you can't go past 0 because that's what we were told. So you have to start here. We can't go past x equals 0, and the line only goes this way. And lines go forever unless you're told they stop. So we're told they start at x is greater than 0. The range is the y values. And so think the top and bottom when you think about range. So what are the possible y values? Well, the highest point on the graph is -2. And the graph is all below that. So the range would be y is less than or equal to -2. Domain and range are one of the trickier concepts you'll learn in algebra. You'll cover it in this class, in your next math classes, and it's always a point of confusion. So you might want to rewatch that and think about that a little more. But the range is always the possible y values. So look top to bottom. Okay, let's look at 2 more. So the domain is from -2 to 5. So that means you probably want to put -2 and 5, and let's put 1 point in between when we're graphing them. You really only need the 2 points, but usually it helps to find a third point. And then I don't like this form because I'm going to have to like kind of, manipulate the equation every time. So let's add 2x to both sides. Now y is by itself, which is what we have done so far. And now you can fill these values in and plot. So we'll do that kind of quickly. Pause the video and try it on your own. -2 times 2 is -4, plus 3 is -1. And then when you plug in 0, you get 3. And then notice these are different spaces apart, so I shouldn't see a pattern. But when I plug in 5, I get 13. So 2 times 5 is 10, plus 3 is 13. That's going to be a little off my graph, but we'll kind of adjust for that. So -2, -1, 0, 3, and then 5, 13. We'll put it up here and call that 13. And so because my domain starts at -2 and ends at 5, I don't go past those points, and that's very important. If you were to continue drawing this line with an arrow, you would be wrong because the domain is all the possible x values. So you can't go to this point down here, -3, whatever it might be. -3 it would be, but it's just not allowed. The range, remember, you think top to bottom. So my lowest y value is -1, and my highest one was 13. And so the range would be -1 is less than or equal to y, which is less than or equal to 13. Okay, give this one a try. Pause this video and try to solve this on your own. And it says the number of pages the student types is given by the equation P equals 4t, where t is the time and hours spent typing. The student plans to type for at most 2.5 hours. Graph the function and identify the domain and range of the function. So let's make an XY table. And we have P is 4t. So that means this is t and this is p. And it probably should use t and p over here also. So I could type for 0 hours, and if I do that, I get 0. We could do 1, let's say. If I do 1, I get 4. And anything in between there, I could type 2. The highest I can go is 2.5, so let's jump up to 2.5. 2.5 times 4 is 10. And so now we have some points we can plot. We have 0, 1, 4, and then 2.5, which is in between 2 and 3. So right in here is going up to 10. And connect those to make our line. And then the domain is in between 0 and 2.5. My range is in between 0 and 10. And so let's talk about those a little bit. My domain is all my possible inputs. So the least amount of time I could spend typing is 0 hours, and the most is 2.5. My range is all the possible outputs. So those are all the number of pages, number of pages I can type. So the least amount of pages I can type is 0 if I didn't type at all. And if I type for 2.5 hours, I can type 10 pages. And we'll stop there with this video. If you have questions, please let me know.